We shall do a few more problems based on the concept of relative motion. A truck starts from rest with an acceleration of 1.5 meter per second square, while a car 200 meter behind starts from rest with an acceleration of 2.5 meter per second square. How long will it take before the car catches up with the truck, and how much distance is traveled by each of them? This question can be done in another way also, so you don't need to apply the concept of relative velocity, but the concept of relative velocity will reduce the steps that you have to write, or the problem can be solved very easily without writing much steps. So let us see how this can be done. So we will assume that the truck is at rest, and therefore the acceleration of, already it is mentioned that it is at rest, but in order to find the relative acceleration, we will assume that the truck is at rest. Therefore, the acceleration of the car with respect to the truck will be 2.5 minus 1.5, which is equal to 1 meter per second square. They are moving in the same direction. So relative acceleration is 2.5 minus 1.5, which is 1. Now, the distance between the truck and the car at that starting point is 200 meter. So the distance that the car has to travel with respect to the truck is 200 meter. This is the relative displacement. We have the relative acceleration. Now we have the relative displacement. We assume that the relative velocity is 0. So u initial relative velocity is 0. uct is equal to 0. So let us write the equation of motion as equal to ut plus half a t square. So relative displacement equal to relative velocity plus half into relative acceleration into t square. So let us simplify this. This is 200 equal to 0 plus half into 1 into t square. So this will let us write it here. So this is equal to t square equal to 400. Therefore t is equal to 20 seconds. So the time in which the car will cover a distance of 200 meter with respect to that is the initial relative displacement. We have assumed that the truck is at rest. Therefore, the distance that, or the relative displacement of the car with respect to the truck is going to be only 200 meter. So with an acceleration of 1 meter per second square relative to the truck, the car will cover this distance in a time of 20 seconds. Now we have to find the distance traveled by each of these two in this 20 seconds. For that, again we will use the equation of motion s equal to ut plus half a t square. So for the car, so the distance traveled by the car, ut 0 into t plus half into what is the acceleration of the car, 2.5 into t square, which is 20 square. So this will be equal to 400, 2.5, 200, this is 400 by 200 into 2.5, which is equal to 500 meter. So the distance traveled by the car in this time is 500 meter, and at the beginning the car was 200 meter behind the truck. So in the same time the truck will cover only 500 minus 200, which is equal to 300 meter. So that is the distance traveled by the truck during the same time, because the truck was ahead of the car by 200 meter at the beginning. That is why the distance traveled by it is less than 200 meter compared to the distance traveled by the car. Okay, right. Now this is the next one. Two trains, one traveling at 72 km per hour and the other at 90 km per hour, are headed towards each other on a level track. When they are 3 kilometers apart, both the drivers simultaneously apply their brakes. If the brakes produce equal retardation in both the trains at a rate of 0.25 meter per second square, determine whether there is a collision. So this is again, as I told you, we are doing problems based on the concept of relative motion. So let us write down the relative velocity and relative acceleration of the two trains. So that let us call them as train A and B. So for the train A, the velocity of the train A is 72 km per hour. 72 km per hour. We will convert it to meter per second. So while converting it to meter per second, we will get 72 into 5 by 18. This is equal to 20 meter per second. Then the velocity of B will be 90 km per hour. So 90 km per hour. This is equal to 90 into 5 by 18, which is 25 meter per second. So now we know the velocities of the two trains in meter per second, and further they are moving towards each other. So the velocity of A with respect to B will be 20 minus 25, which is equal to 45 meter per second. VAB is VA minus VB, but they are moving in opposite direction. So this must be VA minus VB, which is 45 meter per second. Similarly, what will be the relative acceleration of A with respect to B? This is their individual accelerations are 0.25 meter per second square each. So it will be 0.25 plus 0.25, which is equal to 0.5 meter per second square. So we have obtained the relative velocity and the relative acceleration. Now what we are going to assume is one of the trains is at rest. Say the train B is at rest. Then the train is heading towards B at a speed of 45 meter per second and also with an acceleration of with a retardation of 0.5 meter per second square. We assume that the train B is at rest, and then the train is heading towards B with a speed of 45 meter per second and with a retardation of 0.5 meter per second square. So let us see how much distance it has to cover to make its velocity equal to 0. So we will use the equation v square equal to u square plus 2as. To avoid the collision, the final relative velocity should be equal to 0. So this should be equal to s is equal to u square by 2a, or this is equal to the relative velocity is 45 the whole square by 2a, 2 into 0.5. So this is 45 the whole square. So 45 the whole square, this will be equal to 2025 meter. That is the square of 45. 2025 meter, which is 2.025 kilometer. So actually they are now separated by 3 kilometers. The minimum distance the distance that one train has to cover to avoid the collision is 2.025 kilometers. So clearly there will be no collision. So the present separation between them is much more than the distance required for them to avoid a collision. Therefore, clearly there will be no collision. An elevator car whose floor to ceiling distance is equal to 2.7 meters starts ascending with a constant acceleration of 1.2 meter per second square. 2 seconds after the start, a bolt begins falling from the ceiling of the car. Calculate. There are two questions: the time after which the bolt hits the floor of the elevator, the net displacement and distance traveled by the bolt with respect to the earth. So we will do the first part of the problem. The first question which is say, that is the time required for the bolt to hit the floor of the elevator. For this, we will first write the relative velocity of the bolt with respect to the elevator. So velocity of the bolt with respect to the elevator is assumed is 0. And the acceleration of the bolt with respect to the elevator will be g minus a, which is equal to g plus a. So these are our the two quantities that we require to solve this problem are the velocity of the bolt with respect to the elevator and the acceleration of the bolt also with respect to the elevator. Now the bolt has to cover a distance of 2.7 meter in the downward direction with an acceleration of g plus a. Let us see how much is this g plus a. So acceleration of the bolt with respect to the elevator is g is 9.8 and this is equal to 1.2. So this is 1.2, 9.8 plus 1.2, which is equal to 11 meter per second square. So the bolt will be going down with an acceleration of 11 meter per second square, and it has to cover a distance of 2.7 meter starting from rest. So let us see how the time can be calculated. We have a formula which is t equal to root of 2h by g. So let us write t equal to root of 2h by g. So this is equal to root of 2 into how much is the distance that the bolt has to cover? It has to cover a distance of 2.7 meter. So this is equal to 2.7 divided by 11. So we have to simplify this. Upon simplifying this, we will get the time as 0.7 seconds. So this is the time in which the bolt will hit the floor of the elevator. We have used the concept of relative motion here. We assume that the elevator is at rest, and then the relative velocity and relative acceleration, both of them are written here. Both of them we have found out the values of both of them, relative velocity and relative acceleration, and then use the formula T equal to root of 2h by g, which is the time required for a freely falling body to hit the floor if dropped from a height h. So substituting all the required values, we got the time required for the bolt to reach the foot of the elevator as 0.7 seconds. Now let us go to the next part of the problem. This is the A part of the problem. Now we will solve the B part. Now what is our B part? In the B part, we have to find the net displacement and distance traveled by the bolt with respect to the earth. That is very important. We have to calculate the net displacement and distance traveled by the bolt with respect to the earth. See, the bolt had fallen from the elevator after 2 seconds from its start. So we have to find the velocity of the elevator after 2 seconds from the start. So we will first determine the velocity of the elevator 2 seconds from the start. So for the part B, let us start with the velocity. Initial velocity is 0 and the acceleration is 1.2 into 2. So this will be equal to 2.4 meter per second. So the velocity of the elevator after 2 seconds is 2.4 meter per second. Now we have to find the distance traveled by the elevator in 0.0 seconds with this velocity 2.4. See, only after a time of 2 seconds the bolt fell from the roof of the elevator. So at the moment when the bolt was falling, the velocity of the elevator was 2.4 and the bolt hit the floor in a time 0.7 seconds. So we have to find out the distance traveled by the elevator during this time. So let us write the equation as equal to ut plus half at square. So 2.4 into 0.7 plus half into elevator has an acceleration 1.2 into 0.7 the whole square. So let us simplify this. Upon simplifying this, we will get the value as 1.98 meter. So the distance traveled by the elevator during the time the bolt reaches the floor of the elevator is 1.98 meter. So now we have to find the displacement of the bolt. See, the distance traveled by the elevator is 1.98 meter in 2 seconds, and from the floor or from the roof to the floor, the elevator there is a height of 2.7 meter. So the net displacement of the bolt will be S dash equal to 2.7 minus 1.98, which is equal to 0.72 meter. So that is the answer to this problem. The first question in the second part, B part, what is the displacement of the bolt with respect to the ground? It is 0.72 meter. Now we have to find the distance traveled by the bolt. See, in order to find that, let us see what is actually happening here. The moment the bolt is released from the roof of the elevator is going up. So the elevator is going up. So the bolt also will have a tendency to go up initially. It will go up to a certain height, then stop, and then come back to hit the floor of the elevator. By that time the elevator had moved up. So this is actually the path followed by the bolt. It goes up initially because the elevator is going up. So the bolt will also go up at the moment of its release. Then it will go to its maximum height and then return to hit the floor of the elevator. By that time the elevator is also going up. So now we have to find the maximum height traveled by the bolt once it was released from the ceiling of the elevator. For that we will use the formula h equal to u square by 2g. Now what was the velocity of the elevator, the moment when the bolt was released? We have already found it out. It is nothing but 2.4. So we will write it as 2.4 the whole square divided by 2g, which is equal to 2 into 9.8. So upon calculation, this will give us 0.293 meter. If you calculate this, you will get a 0.293 meter. So this is the maximum height reached by the bolt. Then it has to travel the same distance downward. So the net distance traveled by the bolt will be S equal to 0.293 upward plus 0.293 downward plus the distance traveled by the elevator during this time, and that is nothing but 0.72. So add all these two, you will get 1.31 meter. That is our final answer. 1.31 meter. Clear? Okay.